came up with a nice idea a couple of years ago as to use for the storage engine interface. There's no actual, well, in a storage engine you store data and you want to retrieve that same data out with hopefully no corruption. The idea of a computation engine is much like it's installed the same way as a storage engine, but the data you want to retrieve out from it is not necessarily the data you put in the first place, but it's based upon that data you put in. In the case of the graph engine, it's an example of this application where the data you put into the engine are basically the edges of your graph, and what you can then query out from it is basically a route through those edges. And so the data you're now retrieving out from the storage engine is generated data which was not originally put in the first place. This can be seen as a kind of like a computed view, but MySQL at this time does not have a materialized a computed table. But it was an interesting application of it where the idea is to try and make it so that the query of the optimizer can then ask the data from the storage engine in an easy way, which you can then take apart the search and basically perform the operation as required by the user. There's actually a few interesting things if you're ever interested to implement such a thing. If you tell MySQL from your design that you've got a hash index and that on your table flags that you want the whole index, the whole key, you will actually get that as part of your when MySQL tries to perform an index lookup. So that can be used as a way to obtain the parameters of your search, and this is actually used in the graph engine. So you can specify the start and end node of what you want to traverse through the graph, and also what traverse algorithm you want to use. It works out as a lot simpler than originally anticipated, because fortunately MySQL's optimizer was easy to fool. In the case, what you have to do is make it so that the brute force random, the brute force scan through the table is exceedingly expensive, so that it will trick the optimizer into performing a index lookup instead. The other thing you have to do is also make sure that your hash key is non-unique, and by doing that you can then return multiple rows rather than just returning back one row from the hash key. What I was hoping to do is have a little off session later where we can pick apart how the graph engine works and also toy with the use of it. So if anyone's interested in that, that will be later today.
Alright, I'm going to say a little bit about MySQL cluster and cluster J. This is a preview of stuff that will be announced next April at the MySQL Users Conference with cluster 7.1 release. So, quick overview of MySQL cluster. Anyone who doesn't know, there are data nodes that actually store the data. One of them can go down and the data is still there, it's still available. And you get to it through any number of MySQL servers, and the MySQL servers have the same view of it. You can write to them, you can read from all of them. And doing that, you can do anything through the MySQL server, but MySQL cluster is capable of some pretty incredible performance. But when you go through the MySQL server, you don't get that. So to really get the performance that's possible, you go down to the low-level API, to the NDB API. This is some dozen-something C++ process with about 700 methods and 500 pages of documentation.
Awesome.
So not the funnest thing in the world to use. And I'll tell you about cluster J. So this is a project with 3 parts: JTie, NDB JTie, and cluster J. And the end result is being able to use the NDB API from very high-level Java code as object relational mapping, like, store it, delete it, persist it, whatever. So, but I'm going to go through a little history here of mappings of this API to Java, because what we're working on here is the third one. First, Jim Allen did NDBJ in about 2006 that took as much of it as he needed and made it work from Java, right? So a big C++ API and get some amount of it to work, completely writing the code by hand, right? The second was Monty Taylor here using Swig NDB bindings. So kind of feed the NDB API into Swig and it creates bindings for Java and Python and Perl and a bunch of languages, right? And then this project, so JTie is a new generic system to basically map any C++ API, no matter how complex it is, to Java. NDB JTie is a mapping of the NDB API that uses JTie. And then ClusterJ is the high-level Java stuff, JDO, OpenJPA on top of that. So why did we do this? Why did we not use the bindings? This is what I just said, isn't it? So I'll go to the next slide. Why did we not use NDB bindings? And actually, we do. ClusterJ will run on top of NDB JTie, and currently, at least, it still runs on top of NDB bindings. Whether we leave that in, I don't know. NDB bindings, the Swig stuff it's not hard to manage. I guess it's pretty straightforward. The generated code is like 60,000 lines, including this monster 20,000 line ndbj.cxx file. It contains most of the mapping of the API, and then another 20,000 lines of Java. What we've got JTie is 2,500 lines of implementation and 14,000 lines of testing. And this is this generic library that just typeface will map anything in C++ to something in Java. And then NDB JTie, the generated code on top of that, is about 9,000 lines. So not quite an order of magnitude smaller.
Do you have a number right there? It says 25,000 lines. You mean 2,500?
2,000, so JTie 2,000.
You have 25,000.
Oh yeah!
25,000.
Strike that zero.
Pay attention to the comma, not the zero. Okay. So, and then on top of this is, I'm not a Java programmer or a Java object relational mapping person, really. But, what I've seen it, one more thing I gotta say. So in ClusterJ, there's transparent fast path and slow path. You need to do an object.
Finish your sentence.
You need to do an object operation. Maybe it goes through the fast path of NDB. Maybe it goes through the slow path of JDBC. The developer never sees the difference, and that means this API looks exactly like JDBC. The way it gives you the data, and the way it does it.
Thank you.
Yeah.
Last year, I did a presentation on Sphinx in general, and I will just give some little update to what has happened over the last year. So, that's all important stuff. So, do you guys know what Sphinx is? Some of you should do it. If you don't, you can go. That's a full-text search engine with some fine features. So, over last year, we got a couple more branches, now like 3 different branches. 098, which is stable, 099, which is frozen and should be actually in RC stage right now. It should be released in I think a couple of weeks. Release 0910 with some kind of new brand new features, and there is also 10, which gets a very significant changes in support for real-time update, and that is kind of big because one of the major issues for Sphinx for people was that it requires you to reindex the data, which is as fast and so fast later on, but you have to reindex the data, no real-time updates. So in 099, you can actually go natively speak to that using MySQL protocol. That solves a pain for a lot of people who say, how does my API exist for Sphinx? Well, as soon as you can talk, as long as you can talk to MySQL, it does. It also solves problems like, well, persistent connections, connection pool, all this kind of stuff which is usually solved in MySQL is now supported. And it is done kind of similar to MySQL proxy. It is completely standalone protocol implementation. It doesn't use any MySQL code. Yeah, I code this. So it has its own parts select, and most of the stuff is single table selects right now with a bunch of arithmetic extensions and a lot of things which are specific to full-text search or how people use things. For example, when you're doing group by, you also can specify what kind of elements you want to pick from that group. Right? Let's say the most relevant element from the group or the highest priced element from a group, something like that. Now in 0910, what you get here is somewhat similar to Apache. We now get Sphinx to run in multiple modes. So previously it was fork on each request, and right now you can either make fork or do pre-fork, somewhat like Apache, or you can also use threads, which is especially helpful if you're running in Windows, which doesn't really like forks too much. That's kind of a bit interesting how we came to that. We assume forks are fine because when people do full-text search, well, we're speaking about a few milliseconds of response time typically to start with. But there are some people like correctly say, you know what? We chop our data in so small pieces, we want full-text search to be taken sub-milliseconds. And at this point, the fork overhead becomes pretty significant, so we had to do pre-fork and stuff like that. String attributes, that's another stuff that people wanted for a lot of time. Previously, Sphinx would allow you to store floating points and integer attributes or multi-value attributes. Now you get Sphinx, so support for Sphinx as well. And finally, unlike full-text search index update. So you could be updating attributes in the Sphinx for a while, but you couldn't update a full text, which is being indexed. And this is done in a very nice way. I think somewhat similar to Google approach SS tables. We get like things accumulated in memory, and then up to a certain point, then it's dumped and merged. And this stuff gets quite fast, right? You can pretty much be bound only by network. And also, you can insert multiple blocks, and then only when you do commit, they become kind of searchable. In this case, you can optimize things significantly, and really, in full-text search, this approach becomes maybe only like 2 times slower than completely rebuilding indexes, which I think is very good because if you look at full-text search. Like native full-text search speed for Sphinx, it typically was like 10 times faster than this. Okay, blah 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 blah.
A couple months ago, Mark Hanrahan and I had a discussion sort of over blogs, and so we concluded that a Zipfian distribution would be a better match for measuring, trying to predict the kind of performance that we would get from running real data than a uniform random distribution for indexes. So iiBench is this benchmark that I talked about last year. It's a benchmark that inserts data into a database. There is a primary key, which is an auto-increment key, so that's easy to deal with. It's got 3 indexes, which are essentially random. As you get out to 1 billion rows, it becomes a problem when you have only over a couple gigabytes of RAM because it doesn't fit anymore, and this kit starts moving slowly. And so Mark, like that, he converted it from the C++ code that we had to Python, and that's the state of the art. So we discovered, basically this dialogue that we needed to have a different distribution than the uniform random distribution. because the world isn't uniformly random. Some things occur much more often than others. So a Zipfian distribution is one that, for example, models the frequency of words in a natural language. It says that the second word occurs half as often as the first word, and the third word occurs 1/3 as often as the first word, and the ith word in general occurs 1/i times as often as the most frequent word. So that's a Zipfian distribution. So we went and modified, here's the class, we modified iiBench to implement Zipfian distribution. So I thought I'd spend a moment showing you how this works. Here's the code that actually finds the code. And what we did is we made a big array full of numbers that exhibit a Zipfian distribution. And then we fetch a random one of those. So that's what this code does, is it basically grabs a random number and then looks up in this cache, which is just an array, random value. And to fill in that number, basically we had to create an array. And what we did is we filled in a bunch of values, and the number of items we filled in, well, when I was 1, we filled in a certain number of those values. Cardinality might be 1,000,000 or something, so we filled in 1,000,000 ones. And when I was 2, we filled in 500,000 of the second thing, and 1/3 of a million of the third thing, and so forth. And thereby build up this big array, which for the interesting data sizes that we're talking about, it turns out that the Zipfian distribution, when you actually make that array, is sort of, for interesting data sizes, is about 10 times bigger than the actual array. So if you say I want a Zipfian distribution where there's 1,000,000 distinct values that are going to appear, you need an array of about 10 million in order to make that happen. And we did all this in order to make this code run really fast because we were finding that it was running too slow. So we went and made that work, and it's great. And then we measured it, and so here's the performance difference. This is NODB. In green is the uniform distribution, and in red is the Zipfian distribution, which, if anything's worse, so I can't explain what's wrong with that. And it's basically indistinguishable. So the experiment, I don't know whether it's a failure or what, but it hasn't done what I want. And the performance for the Tokutek database is still faster, and it's essentially indistinguishable from the previous one. I don't know whether that's one data line or 2. So
you haven't gone far enough in your asymptotics. Put a 10 billion rows in there and maybe
well, you can get iiBench off the web and you can try it. It's a launchpad.
Naturally dead in there.
I would really like to know what I'm doing wrong that's not making this, because Mark and I thought it was going to be like 10 times better. Is that Mark?
I care.
Does that sound right? We thought it would be like 10 times less disk misses or something.
How did you insert the data? It also depends on which order. If you still need to insert them in random order, I mean 1, 2, 3, and then you do all the ones and everything else, you still get quite a lot of 6. And if you would first insert all 1s, all 2s and 3s, then you would get totally different.
Well, we're inserting them in they're random. It's a Zipfian. It's randomly chosen numbers with a Zipfian distribution, so it's not going to be in order, because that's not what happens when you trickle load data.
That's the thing with if you look at real data. Usually you get data from a region like zip codes. So you get everything in one region.
Well, that's not a hard problem to index if the data is coming in a sorted
No,
order.
but usually you get them in clumps.
Well,
Monty, but our whole discussion on Zipfian came out of a block trace that I took from NODB, where I was actually looking at the pattern of accesses to blocks. And I fit the curve, and I said, hey, I don't understand this, who can explain it to me? Looking for free help. And Bradley took the bait and explained
That
the
is not
distribution.
available.
This was for a production server, so hundreds of tables over 24 hours. I got all block accesses, and then I looked at the miss rate as a function of cache size. And with that result, miss rate as a function of cache size was fed by Zipfian.
so there's some things I don't think we completely understand about this, but we're making some progress.
Thank you, Bradley.
So thanks.
lightning talk. This is my query. This is how it looks like as a syntax tree. So what every node knows their parents and their children. And what happens to create such a syntax tree, JJtree allows you to annotate or parse the grammar, and like you see Hassan in custom, you give the name and you define how many children it will have, and it uses tags to put all the nodes. And I also worked with Coco, and Coco didn't have such annotation, so I mimicked the way JTree works and put all the the similar functionality there. So here is my node class. It has parents and children and one thing except method, which allows you to visit the structure, the syntax tree. So visitor is to support everybody know, I'm sure the nodes. And where did I start doing it? I had data in one line. It has some structure, but I don't know what structure is. So, and I had to query this data, like select star, where price smaller than this one, or and you can select color. Here, price is unknown field. We don't know how to, we don't know from the data. What visitor design pattern allowed me is that I was able to push lots of functionality to the field nodes, and for example, for price field node, I was able to pull the correct extractor using other, of course, packages. Was able to pick appropriate extractors. Okay. So what we did using the similar design pattern, I was able to process these lines through scanning, like each line was passing through the query and it was being interpreted. And if it qualifies, then you would put it into the table or result table. And we also did, for where part, we did cost analysis for extractions. And for another project that I worked during the summer of Google Summer of Code 2009, I wrote a parser for MongoDB, NoSQL language grammar. And what we did, we have currently do semantic check, like table exists, or you have select field 1, field 2 from table 1, table 2. You kind of some fields you have, and etc. So we'll start. I have to start generating the code using the same pattern to query the DB cluster. Thanks. You can check out the code. Thank you.
Well, my name is Tom Hanrahan, and I'm from Microsoft. And when I was meeting people this morning, I wanted to be surprised that Microsoft was here. There's actually 300 people from Microsoft here right away from me.
Can you speak up, please?
Drew Spencer and Bernardo Zamora.
Please.
The reason we're here, the short answer is Liz Grimmer invited us. So for those of you who know Linz, I met him at the PHPN conference last month. The second reason is Microsoft is really attempted to integrate open source onto Windows. And naturally, we support the native Windows stack. So that for the web, that means IIS web server, SQL Server database, and ASP.NET tech applications. But we really put in programs in place over the last several years to support other stacks on the platform. Specifically, the Windows IIS SQL Server P stack. P stands for PHP, Perl, Python, and Pajama. There are several things that we had to do. One, we had to create a fast CGI model that took care of the process and threading model differences between Linux and Windows. We gave resources available to the open source development communities. We have virtual machines we can set up in Redmond that we can give access to. At the same time, we can gave. And in some cases, we can use physical hardware. In some cases, we can use some sponsored. We're also committed to supporting middleware. So in this case, supporting Windows, IIS, databases like MySQL, MariaDB, Mongo, CouchDB, and all of those combinations. And the rest of this alphabet soup, including the Apache web server, and what it really amounts to a complete open source stack sitting atop the Windows platform. We're also committed to interoperability, and we've got this interoperability gap between all the Windows stacks and Linux. And the way we try to solve that is through virtualization, where we support all the Windows stacks and physical hardware, all the Windows stacks on top of our hypervisor solution. I'm writing this on open office source, not resolving. Also running the lab stack, and then committed to having System Center be able to manage all of this together. So the message I just want to give you is that we're really committed to running open source stacks, middleware, applications, and where we can help you with programs like providing resources and in some cases financial sponsorship. Thank you.
Trainwreck is a funny project. It has been
Do you use slides?
No. So Trainwreck is a funny project, as in MySQL replication. To have it in more efficient ways, you kind of rebuild that Trainwreck. So it is a software, it is an agent. It connects to MySQL, it reads the MySQL replication protocol, and instead of like, and then what it does, it just connects to another MySQL server and applies those events. So as simple as that is a kind of separate user land replication agent, which can do filtering by databases. And what it can do is it puts the position of the replication into the machine it replicates into. So what you can do is, you can use Trainwreck to do some basic replication filtering from one server to another. You don't have to do inside MySQL. What you can also do is run multiple Trainwrecks. So this is how it originally it's fantastic. So see, there are two projects. There is Wikipedia, which is kind of like, website, lots of clicks, all the high performance. And I want that database environment to be like modified whatever I want. And there's a tool server project where all the various community people run their tools. And they don't really care about scale out that much, and sometimes all they want is like, can I please get all these replication streams from all the 20 distributed machines hosting all the text into this single machine, because we don't use that text much anyway. So they had to build like multi-master replication, and which database is it easy? So I mean, it's easy if you build an agent. River built an agent. It was a kind of single human project, which you can actually see because right now it works only on Solaris, because it uses some Solaris own APIs. River likes Solaris. That's the single thing why it is just on Solaris. But as in, like I played with it a few times and ditched all the Solaris bits out, but never made a proper project out of that. So Trainwreck essentially allows you reading from multiple masters. You can run multiple Trainwrecks on multiple different databases on single. Oh well, good so. So you can run multiple Trainwreck processes to run actual parallel replication from single machine. It's just by database, but you can have multiple database streams combined together on the same server. And also Trainwreck allows you to do kind of, once you go really crazy, is like, how do I replicate these two databases to this server and these two databases to this server, but those three databases to that server. So once you really want to build any kind of dynamic changing replication topologies, you go for Trainwreck. It's like, how do you find it? You type Trainwreck into Google and maybe you'll find it.
What are you using to read MySQL bin logs?
MySQL bin log Duncan protocol. So it connects to MySQL. It acts like a slave. It is a MySQL slave by itself, but instead of so the actual problem with MySQL replication, the actual difficulty is how to write the bin log, and implementing the replication that the apply thread is kind of a hacking project that can be done quite fast. It's like all the work has been done in writing the bin log, so it's actual if you look at it from that perspective, MySQL replication is like really thin layer on point-in-time recovery bin logs. As in, that is where the real logic is. So actually, tapping into that and then applying that on the different server. I mean, if you really want that, you can just write different code that it can replicate to Postgres if you really want that. But I mean, it's possible if you handle the deals yourself. So yeah.
I like it. Would you write it in?
I didn't write it. It's in C++. I wrote. I was kind of, you know.
You're just sharing it with us?
I'm the guy who knows the MySQL, so I was the guy who was kind of like, yeah, this is how you implement it, and someone implemented it. So, but it was written to bypass me. It wasn't. You know, yeah, I mean, eventually, I really hope that it will have Trainwreck evolve into something where you can just type a command and it runs and works and does what you need. I mean, it's really like having such a tool is something I really want in my daily operations. And I mean, for especially when you do sharding, resharding, how you combine multiple streams, then you can really have point in time different kind of replication stream combination set up by just simply, you know, not doing that inside MySQL, because doing inside MySQL, have to go to Mark and ask for features, and you'll get a billion of even if you get it next day, deploying that build might take a lot. So yeah.
Oh, that's fun.
That was my first book.
Okay, thank you. My name is David Lutz. I'm the Director of Technical Sales Consulting. There will be no sales pitches in this, though. I don't really work for sales. This is Infobright's second year at OpenSQLCamp. So last year, if you were here before, you would have seen Alex Hesterkin, who was our chief architect at that time. This year, our chief technology officer was going to attend and had to go to our development labs in Europe at the last minute, so I am a substitute. And what I wanted to talk about was column stores, because Infobright is a column store. And I did want to reach out to the guys at CalPont and DynamoDB and say, I'm not the only column store guy here, right? So this is really great validation. That this is something I think in the database world we have to consider. And the reason I say consider it is because column stores are a specialized engine for specialized needs. It is not a generalized technology. So just to step back, what is Infobright? Number one, we're a software-only company. Number two, we are a database company. Three, our database is built on and distributed with MySQL. So we are sort of MySQL-centric at this point in time. Our platforms that we support are all flavors of Linux. We also support Solaris from the typical Unix stack, as well as 32-bit and 64-bit Windows. So there's a lot of different platforms that you may run, or you may have clients that run on that you want to look at Infobright or column store technologies on. If that's one of them, and that's almost all of them, Infobright would be a good fit. Another thing about Infobright is that we are a commercial open source company, and that's why we're here. We're an open source company. We have an open source offering. You can download it. It's called ICE. I know it's a cheesy name, but it's Infobright Community Edition. It's freely available at infobright.org. You can download it on any of the platforms that I've just discussed. There also is a commercial offering. It's a commercially supported product. You get it from the company. We provide services, training, support, indemnification, all of those great things. And of course, there are differentiations between the free community software and what we call the enterprise or commercial software that go beyond, corporate support. One of the biggest things that you will probably run into looking at, if you were looking at Infobright Enterprise as opposed to commercial, is DML. Our community product is a load and read product only, which means it's one of two things. It's either load your data, analyze it, and throw it away, or download it and evaluate Infobright Community Edition before you decide that you might want to use it for a commercial or a production environment. So why column stores? That was the Infobright pitch. That was as close to sales as it's going to get. The thing about column stores is, and it's very trite to say this, but column stores fit where you're doing columnar operations, right? It's all about I/O reduction. A lot of the advances that we've seen in database technologies, and I'll say SQL database technologies anyway, the advancements and the alternatives that have come up have all been about big data. How do you solve the big data problem? Well, part of the way to solve the big data problem is not to read all the unnecessary noise. And that's what a columnar operation is. I've got X columns and I only need to read X minus N number of columns for my query. So don't read those columns. The only way you can do that in a database is to have a physical architecture that doesn't force you to read every columnar attribute for every record. and have every record perhaps on a page where you have to read records you're not even interested in. That's the expensive part of the database, the I/O operations taking off disk across the bus and into memory and then throwing it away. Okay? So column store databases are specifically designed to allow you to reduce the I/O that is necessary to resolve queries that only ask questions of a small number of columns. Maybe it's giving me an aggregate about a column. Maybe it's giving me some of the content from that column. And probably, perhaps, even more regularly filter on a different column. Well, the way that you do it in a lot of regular relational databases is you use indices. What's unique about Infobright compared to other column databases, no indexes. So when you have no indexes, what's that mean? Less space. If you have less space, that means less bytes on disk because you're doing less reads. Again, I/O reduction. Another thing that we do, and this is what all the column stores do, is we compress the data before it goes on disk. So again, column databases give you a reduced I/O rate because you're reading less off of disk. I think I'm probably close to 5.
10 seconds.
I can barely introduce myself. So that's it. I'm going to leave it right there. Infobright.org, Infobright.com.
Hi, my name's Joseph, and I like to play with data. And it's good that I was following Dave because part of what I'm looking for in a solution to how do I do statistics with SQL is column store databases. Way back in the 70s and 80s, I was doing pair programming with Fortran programmers, turning algorithms into software. It was pair programming. We sat down together, I would write math, and he would write software. We did things. Did that through the 80s. Then I started playing with data through other people's algorithms using SQL and relational database management systems, and then later business intelligence systems, and most recently playing a lot with Metapa and using that. And I'm going to make a lot of statements, but I really have a question, and I know of 3 ways that I can start doing real statistics with SQL databases. And I want to do real statistics because the most you can get just with average is assuming that I have a uniform distribution or a normal distribution, and even in any cases, an average isn't necessarily the mean. And the mean is certainly not the best descriptor of the underlying distribution of the data, right? So I can start doing fancier algorithms in SQL, but they're painful. And if you know algorithms, you know, the big O number, you know, they're nasty big O numbers to do, even if I have a frequency function to try to arrive at what it mean. But if I want to do Bayesian statistics and do a Markov chain Monte Carlo simulation to get at inferences on mathematical conjugates, I'm not going to do it in SQL. So I have 2 other choices that I've been exploring. Anybody here familiar with the R project? Yay! Yeah. All right, I love the R project. And I'm having a lot of fun with the R project. The R project is written in R and C and Fortran. And there are thousands of packages written in Fortran and C. I'm doing a lot of nice math with it now. And that's a lot of fun, but everything in R is actually data sets, and data sets are actually column store databases in memory. And even though I can get 8 gigabytes on a laptop now, I can run out of memory pretty quickly with the type of stuff I do. And what do? I use SQL because relational database management systems manage data really, really well. And R analyzes the data really, really well, and R speaks SQL through either ODBC or DBI, and off you go. So I like to use column store databases, and one of my questions is I'm looking for a way of speeding this up so that I can match a column store data set in R in memory to a column store database such as Infobright or MonadDB or LucidDB, and do this one-to-one mapping much more efficiently than I can doing through ODBC. Anybody have any thoughts on that?
TLR?
I have not. I've never heard of TLR.
It's R embedded in Postgres.
Okay, yes, I have. Did you say TL or PL?
PL.
Yeah, PLR I know of.
Yeah. Another
And there's a lot of things like that, but they're basic interfaces. Yeah?
SQL DF.
SQL DF?
Yeah, which isn't all that mature, but it tries to map the name of the data frame that you have in R, so you're doing your stuff in R, to table in your MySQL.
Okay.
Because really what you want is proc-SQL data step relationship on SAS. And I think we have the best.
SQL DF?
SQL DF. And then basically you have to overload the data frame type in order to have it. So when you do an access, you overloaded the access operator to go out to a SQL database rather than however it does it right now.
Okay, great. So SQL DF. A third solution I've been looking at is LucidDB. Is a column store database with a plugin architecture and written in Java, and there is the map commons on Apache.com packages, which have real statistic packages and probability distribution packages and all sorts of really neat packages, which are essentially Java, it's all in Java. And I would like to see real statistics written into LucidDB as plugins, if anyone's interested. Thank you so much.
We were sitting around talking about this earlier, like, really, what is this whole NoSQL thing, and what does it really mean to the ones of us who work on databases? Because, maybe we need a guide back to the NoSQL world. So what we did is, I sat down and asked a couple people, like, what do you think about when you're thinking about NoSQL, and what are, like, the real things that are important to you that comes up? So, at first we did, well, what is even the definition of it? Because it's even kind of hard to understand. We're saying, well, it's NoSQL, but what does that mean? Could that mean it's, is that access? Is that, what exactly does that mean as far as database stuff goes? So, non-relational data stores that do not need a fixed schema and that usually avoid join operations. I like that usually part there. There's actually a question mark where that was coming from Wikipedia. And the first thing I had to sit back and go, well, what does this really mean to us? So a lot of us, we have group by. We've had group by. We understand group by operations. So to us, how do we translate this back down into their world and their terms? And so a group by operation, and the easiest thing to explain to it really is a group by operation is map reduce. We're taking some data, we're coming up with a reduction operator, and then we're applying it. So MapReduce probably is maybe a new term for some of us, but in reality, we've all been dealing with this for a very, very long time as a concept. So, if you're trying to explain to somebody in the database world and they say, well, what is this MapReduce stuff? You just say, well, it's really just a group by. And I'm like, oh, well, I can get that. Just, some. How does that work? And then, but how do we translate this back onto the other side? Because, in the other side of the world, we have the NoSQL world, where they're like, well, what really is joins? What do they mean by, and they're like, well, we don't want joins. So since they don't want joins, what they're trying to do then is it's actually just a multiple MapReduce operation in their case. Because in their environment, there's no need for a join. We just have a lot of data out there, and we can just write something that can go access a lot of that data, across nodes. And this is just multiple MapReduce operation. So that's what it means on their side. On the same token, though, we talk about things like table scans. So what really is, in our world, we try to avoid table scans. Table scans is the last thing we want to do. You don't have any index to your data. You don't know where your data is at. You have to find some collected, you're going to have to go scan all that data to get an end result. So what does that really mean for their world? Well, in their case, that's a multi-machine pattern. So where, we have it combined with a single machine, it's all about, throwing that data out across as many machines as possible, scanning all that data, because, if you don't have indexes, if you have multiple machines working on it, it does tend to work faster. So a lot of that's about a multiple machine MapReduce operation. On the same token, we talk about things like order by with limits. So we have a data set, and we want to do some ordering operation of that data set. And we probably want to have some kind of limits on that, so we don't really reply with too many given row results. In their environment, what they really have is they just call this natural data order. What they're doing is they're storing the data in the natural order that it would ever need to be retrieved in. So there's really no reason for this concept of an order by. Which, by the way, if they do need one, the answer is MapReduce. With a lot of memory. So this kind of helps us out a little bit. On the same token, we talk about what is the real features involving in these NoSQL databases. I mean, what are they're bringing out their features? And so in this case, we have something called, they have called a forward rolling log. A lot of these databases have been implemented, the NoSQL ones have been implemented with the concept that you take data and you apply it onto a log, and you have more data and you keep applying it to the log. And then as you have more data, you keep applying it to the log. And really shouldn't ever have enough data where the log ever gets filled. And this is a feature. And it's a feature that we've never seen anybody in the database ever be made fun of at all. Ongoing. Because we all know from our own experiences that there really is nothing wrong at all with just putting data on the end of a file. It'll never long-term go wrong for you. On the same token, and this was Mark when he was reviewing the slides, he's like, yeah, reinventing MyISIM is not a selling point. On the same token, they talk about the issue of really there is no need for transactions. We have eventual consistency. Why would you really ever be concerned about transactions as a feature? And I've got to say that within our own open source world, we know that there's never been an ongoing joke. Never been an issue. On those same tokens, we look back at that and we think about the question of, well, schema-free, do we really require schemas? I mean, is there any reason why we go through, hours and days and months designing actual schemas?
I like my job.
Because, because really, schemas, because again, when I look at this, my thing is, I know where everything is. Please, because it's really okay to not actually have schemas. Really, when you get down to it, and their final piece of this is that, SQL sucks. As somebody who's worked on, databases for more than a decade here, I agree, SQL sucks. I entirely do not like it. I sit back usually and try to dream up new languages and new ways of solving this problem. And I have to say, so far I've had no luck ever come anything. And when we look back at people and their response to it, unfortunately, it probably is too small for everybody to read back to the audience. But when we look at these problems of how do we get around SQL, there must be ways that we make people who work with us happy. First guy says, how do I query the database? The guy goes, hey, it's not a database, it's a key value store. Okay, it's not a database. How do I query it? You write a distributed MapReduce function in Erlang. The guy says, you just told me to go fuck myself. He says, I believe I did, Bob. SQL is really not much of the answer here, because that would be just too fast. And MapReduce, if we think about it, really is going to help solve our global problem. 6% of the power on the planet currently goes to data centers. And we know that MapReduce won't in any way require us to build many more data centers, just to help our global warming needs. So anyway, thank you, and I hope you enjoyed it.
No slides. No worries. Start timing me.
It's Jonathan.
Hello, I'm Jonathan, Duke Leto. I work on Parrot virtual machine, but yet I care about databases, which is why I want to embed the Parrot virtual machine in Postgres. So there are developers here that know about Postgres internals, which I know there are. You should come help us. I just sent a tweet with the OpenSQL hashtag. If you are on GitHub, you can go to github.com/vo/plparrot. We're basically creating a new Postgres language. It's a bitch. There's not good docs. Postgres internals are weird and have weird freaking names and nothing makes sense in the internal functions. So, I'm trolling all day. So you're all on the same boat. But, I come from the Parrot world and we have great API and we have the word Parrot in every function call. So you're calling Parrot, but shit is, I don't know what the fuck I'm talking to. So, we would love, there's about 5, I would say, serious developers right now. The writer of, there is a PL lol code if you did not know, and you can write lol code in your Postgres database. And I have that guy on board, he's helping Rex and Yak and all this madness. Parrot, I have my parser, I have my language, I have my VM. I just need to know the Parrot, the Postgres internal side to how to jam this in there, and then basically I can, go on my way and, embed Parrot and do all kinds of wonderful things. Why would you want Parrot in your database? Great question to ask me. Wouldn't it be great if you could write performance-critical, cross-platform stored procedures and not have to worry that, oh, we have these 10,000 lines of stored procedures in C, and okay, let's go get that to work on another platform now. Like, good luck with that. Or, oh, let's fuzz our data because, you know what, these clients shouldn't see the real data, and then, the fuzzed data brings out a double free error in your stored procedures that brings down your entire production database. Things like that happened to me, so maybe they've happened to you. So, those things would hopefully be much, much less prevalent. Of course, there could be a bug in Parrot, which you can come yell at me and we would fix it the next day, but hopefully you're not going to be generating double free errors from a dynamic language as much. So, although it's possible. Does anyone have a question? Has anyone never heard of Parrot before, or doesn't give a shit about Postgres, or both?
I can just say that the Postgres guys are too busy. We can help you to get it into MongoDB instead.
If you're from a different database community and you want Parrot virtual machine in your database, come on to Parrot and irc.pro.org and we'll make it happen.
I already have a framework roughly for plugging in dynamic languages into MySQL. Just not. I'm going to be working with one in the future to incorporate.
Interesting. So yeah, we can put Parrot in MySQL. I'm all aboard.
So Parrot and MariaDB.
Yeah, well, yeah. I'm
only on the outskirts of the database community. I'm in Portland. I hang out with Selena. I hear what the Postgres peeps are doing, but I'm a lowly developer. My DBAs and my ops teams makes the database work, and I just jam data in and grab data out.
Can I get that on a t-shirt? To give to people, like I'm just a lowly database developer.
Questions? Comments?
Do you drink black vodka?
I drink good scotch.
Yeah. Well.
Next question!
Can I sit with you two at dinner?
What's that? Yeah, sure.
Scotch and vodka, this would be a good combination.
Any other questions or comments? Yes?
If there were a function in another database that executed a query but was called something like parse query, would that confuse you too?
In what sense?
If the internal function name that executed a query was just called parse query?
That would be logical.
Yeah, okay.
Yeah. Not like in Postgres internals right now. So, yeah, it's just, I tried to look at the internal function names and they seem to be a random collection of letters that someone thought of. That's just me. No, that's medium length. Camel case, Haskell case, a little bit of maybe Hungarian crazy notation. I don't even know. But fast, performance critical, cross-platform store procedures. If you care about that, then you want a VM in your database. People have already put JVM. I'm not, that's not the way I roll. I want open source in my database, and so that's why I pack on Parrot.